Welcome friends, in this one let's answer these questions from the 1997 AP Calculus BC multiple choice section. What are all values of x for which the given series converges a, b, c, d, or e? We have to choose one. Let's begin by doing the ratio test. So it would be the limit as n goes to positive infinity of the following. At first would be x minus 2 quantity raised to the n plus 1 divided here by, and now here this would be n, and then times 3 raised to the n plus 1. Every occurrence of n gets replaced with n plus 1. And then you would have to divide this by that same expression as follows. It would have to then be x minus 2 just raised to the n, the original. And that would be then over n times 3 raised to the n. Then you need to keep change flip on this. So the limit as n goes to positive infinity. And then, let's see, keep change flip. So in other words, you're going to take the top expression, completely unchanged, this one right here, x minus 2 to the n plus 1 over n plus 1 times 3 to the n plus 1. And you're going to multiply by the flipped version of the bottom expression, which would be n times 3 raised to the n over x minus 2 raised to the n. From here, you also want to break this apart a little bit so things are easier to cancel. So that 3 to the n plus 1, you can write as 3 to the n times 3. And the x minus 2 to the n plus 1, you can write as x minus 2 to the n times x minus 2. Then from here, cancel off what you can. So specifically, that means the following. This can be cancelled with this. And then this can be cancelled with this. And then what remains in the next stage is the limit as n goes to positive infinity of the following. X minus 2, and then n. And then you divide this by n plus 1. And then there's also a 3 here. So now, that part that's x minus 2 over 3 can pull outside. X minus 2 could be positive or negative depending on the value of x you plug in. You don't know in advance. So you need the absolute value bars around the x minus 2. The 3 doesn't need absolute value bars, but it kind of just works out that way anyway, because it's in the bottom. And then you'd have the limit as n goes to positive infinity of just n over n plus 1. Well, n is positive, n plus 1 is positive, the ratio is positive. You don't need bars around n over n plus 1 anymore. Now that limit there is 1, so you just end up, in other words, with the absolute value of x minus 2 and this quantity over 3. And then this is basically, that's it, because that limit, again, is equal to 1. So you have 1 like that, you see? Which is the same thing as just writing this in the first place. From here, you're going to do the following. This can converge if that x minus 2 over 3 is less than 1 in absolute value. So x minus 2 over 3, you want this to be less than 1. That means the following. Multiply both sides by 3. That would be like saying that absolute value of x minus 2 is less than 3. You can do this because the absolute value of 3 is already positive 3. So in other words, you could write this left side here. You don't even have to write it that way. You could write it as x minus 2 over the absolute value of 3, and you don't even need absolute value bars around the 3 anymore. So it looks like this once you multiply by 3 on both sides. And then from here, you're going to have negative 3 is less than x minus 2, which is less than positive 3. And then from here, you're going to have the following. Negative 3 and then plus 2 is less than x, which is less than 3 plus 2. And then from here, you're going to have negative 3 plus 2 is negative 1. Is less than x, less than 5. You just have to check now convergence or divergence at the endpoints of the interval of convergence. So when x is the value negative 1, let's see what the series is that we get from that process. You're going to have the summations that goes from 1 to positive infinity, and you're going to have your negative 1 minus 2 raised to the n over, and then n times 3 raised to the n. Work this out. Summations then goes from 1 to positive infinity of negative 3 raised to the n over n times 3 raised to the n. Work this out next. Summations as n goes from 1 to positive infinity of separate off a negative 1 to the n and then 3 to the n this way over n times 3 to the n. Notice that 3 to the n, those parts will cancel off. So it's going to be summations n goes from 1 to positive infinity of the following. Negative 1 raised to the n over n. This series that you get here has an alternator in it. The negative 1 to the n makes the values flip from positive to negative and so on and so on. So in other words, this converges. Converges. It's the alternating harmonic series. I'll call it AHS for that reason. Alternating harmonic series that converges. The next one then, when x has the value here 5, the right endpoint of that interval there, you're going to try it out again. So I'm going to pump this down below. It's going to be here not -1 but 5 now in this position. And then from here it's going to be the summation as n goes from 1 to positive infinity of 3 raised to the n over n times 3 raised to the n. Keep going. So summation as n goes from 1 to positive infinity. 3 to the n cancels with the 3 to the n in the bottom, and you just have 1 over n, like this. And of course, this is called the divergent harmonic series, which means that the final answer then would be the one that corresponds to x being allowed to be -1, because that's the convergent alternating harmonic series at -1, but the one that excludes 5 because that's the divergent harmonic series at that right endpoint of the interval. So E is the correct answer. Please leave a like, please subscribe. I hope it's been helpful. Thank you so much for watching. I will see you in another video.